Okay guys, we're going to work through naming acids today. So we've named ionic, we've named covalent, and the only thing left that we have to do is name acids. There is such a thing as organic compound naming, but that is not information that is in the scope of this course, so we will not be talking about that. So, first thing, how do you know something's an acid? And let's review real fast. So we have named ionic, we have named covalent, and now we're going to name acids. So we need to know how to know which one it is. Okay, if you remember, we said ionic is going to be a metal with a nonmetal. Covalent is going to be a nonmetal with a nonmetal. Okay, these name with, you use Roman numerals for transition. And you just name the ions. Okay, covalent, we're going to use prefixes that show the subscripts. Not show, let's say, that represent. Prefixes that represent the subscripts. Okay, then acids. How do we know it's an acid? Because it starts with an H. So it's got hydrogen at the front. If you're looking at the name, the last name is going to be acid. So it's something acid. All of them. Okay, so getting on into this. The first group of acids we're going to look at are called binary acids. Okay, binary. Bi means two, like your bicycle. It has two wheels. So all of these are two elements. Hydrogen and chlorine, hydrogen and bromine, hydrogen and sulfur, hydrogen and fluorine. Okay? When you name these, okay, all of the names start with hydro. Hydro, 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 hydro. And just like I said on the previous page, they all end as acid. Acid, 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 acid. Okay? You should recognize some root words. Chlor, brom, sulfur. That's one that you use the whole word. It's just weird. You do the same thing with carbon. They're short words, and so you just use the whole thing. And then fluor. So, binary acid. Let me type your little things. Binary acid, two elements. Hydro, root, ic, acid. Okay, and you should be taking some notes, guys, as we go through this, so that then you'll have those notes to refer to when you go to do the assignment. I'm yawning, of course I am, right? Okay, subscripts are from crossing down. Oxidation. Okay, cations. Now, here, this calls it an H3O plus ion. For those of you in advanced and AP, this is a hydronium ion, which is actually what the H plus ion is in the water. So you see how this is a water with an H plus, it makes an H3O plus. But for the sake of this assignment, you can just call it H plus. Okay, H plus and H3O plus are used interchangeably. So that's going to be your cation for all of them is H plus. Okay, and then your anion, this first one was Cl minus 1. No subscripts. 1-to-1 ratio, you don't need any subscripts. This is a 1-to-1 ratio also, so that anion is going to be Br minus 1. Okay, and then here we have H2S. That 2 crossed from the S, so that's why it's S minus 2. No subscripts, so again, this F is going to be F minus 1. Okay, so that's your binary acids. Ternary acids. I don't use the word ternary, I use the word oxyacids because that is going to tell you what they have to contain. And oxy, what do you think they have to have? They have to have oxygen. Okay, so to get oxygen, they're going to have a polyatomic ion. Okay, now if we look, all contain oxygen. If you look at those names, we have root words again. Oh, let's get a pen. We have chlor, we have sulfur, sulfur, phosphor, phosphor, nitri, carbon. Okay, again, carbon is like sulfur. You use the whole word. Okay, so cations always have to be hydrogen. These subscripts are also found from crossing down. Okay, so the polyatomic ion here would be ClO3 minus 1. SO3, there's a 2 on the hydrogen, so that's going to be minus 2. SO4 would also be minus 2. PO3, there's a 3 crossed over, so that's going to be minus 3. NO3, no subscript, so that's minus 1. And CO3, the 2 is crossed over, so that's a minus 2. Now, if you notice, when we look at our endings, we have 2 endings. We have ick, 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 and then we have us, us, us. Okay, so let me come back down here. This and this. Okay, and if you remember when we did transformation of polyatomic ions, we had 8 ions and we had 8 ions. So our 8 ions are going to make ick acids. Our 8 ions are going to make us acids. A little wider. And hit an enter right there. There we go. Okay, so some of these are filled in already. SO4, that's sulfate. So the 8 became an ick, so sulfuric acid. Okay, this one would be, that's 1 less oxygen, so that's sulfite. So that should be sulfurous acid. Okay, ClO4, that's an ick acid. So that means it's the 8 ion, so chlorate. Okay, phosphite, O3, this is O4, so this is phosphate. NO2 is nitrite, so 1 more oxygen would be nitrate. Also, this 8 is an ick acid, this 8 is an ick acid, so that's going to be carbonate. Okay, if you were to be working with a hypocarbonite or a percarbonate, the name of the acid would be, so let's just do this one. Carbonate, if we did H, let me change to a different color. because that green's kind of hard for me to read. I don't know how it'll be for you. H2CO4. So that would be CO4 minus 2. That would be percarbonate. So that's, you keep the per, carbon, keep the ic, acid. Okay, so the per and the hypo would translate directly over. Okay, it's percarbonate, the ate part still becomes an ite. I mean an ic. And the ite part would still become an us. Okay. Um, so, which of these acids would be named beginning with hydro? Well, hydro is used for naming which ones? Your two choices are binary or oxy. Okay, it's binary. Hydro acids have no oxygen, have no O. Hydro acids have no O. Okay, so that would be this one and this one. Okay, and then I'll go ahead and mark these others in another color. The oxyacids would be this one and this one and this one. Okay. Okay, so here's some of those hypo and per. So cation, that's pretty quick. Those are all H plus. Okay, so those cation H plus is all the way down. Okay, those anions, this would be FO2 minus 1 because there's no subscript on the H. Actually, all of these. You see how none of these have a subscript, so they're all going to be minus 1. IO3 minus 1. BRO4 minus 1. ClO minus 1. ClO2 minus 1. ClO3 minus 1. ClO4 minus 1. Okay? Now, if you will notice, the ClO4 is perchlorate. The BrO4 is perbromate. These are all halogens, halogen oxyacids, so the polyatomic ions are all made with halogens. That next to the last column on the periodic table, they're going to all have the same trend in their oxidation numbers and the way that they make their different ions. Okay, so this is perchlorate, so this would be chlorate. Chlorite, this would be hypochlorite. Okay, perbromate, this is IO3, so that would be iodate. FO2, that would be fluorite. FLOURITE. And then that IO would be hypoiodite. Okay, so naming over here, it's going to be the same thing. Okay, this is going to have the per, this is going to have the hypo. Okay, this is going to be, they're all going to be acid. Okay, and then you, these two are eights, so these are going to be ix. These two are ites, and so they're going to be us. And then you just fill in your root. Okay, so this is bromic. This is iod, iotic. This is fluorus. FLOUR, fluorus. This is iodus. Those iodine ones are, they just sound crazy. Okay? So if you got questions, post them. Hopefully you watched the transformation of ions. If you didn't, that would be a good place that you should have started. I probably should have said that at the beginning. Hopefully you're doing everything in order though, and so you will have already watched it. If you need to watch it again to look at this transformation thing, go ahead and do it. That's fine. Watch them as many times as you need to. Okay. So moving on, last page. So here are some with nothing filled in. And these are mixed up. These are oxyacids and binary acids. Okay, so I would pause the video. I would try to identify them as binary or oxy, and then I would try to go ahead and fill in this chart. Okay, um, and so pause me, try this, and then I'll do them. Go ahead, pause it. Okay. So hopefully you're back. Hopefully you tried them. Hopefully you paused it. Um, so you are missing a column here. You're missing the cation column, but do we really need that? We've done it in 3 different tables, and every single time the cation was always H+. So it's not necessary to continue to write that down for every single one of them. Okay, so we just need our anions, we need our acid formulas, we need our anion names. Okay, now what I would do first is I would identify, are they binary or oxy? Binary are going to have what to recognize in their name? We're going to have hydro. So this one is binary, and the rest are all oxy. Okay? So if you needed that to be able to try them, pause me, try them now. Okay, our acid formulas, they're all going to start with H. Okay, and I'm just trying to think through the stuff that would be easiest for you to do to figure out how to, because you can't necessarily go straight across. That's not going to be the easiest thing to do. Okay, we know that this one, hydroiodic, that is going to be HI because it's just the halogen. Okay, and so this is going to be I minus, and this is going to be iodine. Okay, now these oxyacids. So the ones that are ic were 8 ions, right? Yes. The ones that were us were 8 ions. And then do I have any prefixes? I have a hypo. So this would be hypo. So I could go ahead and do the names of these by bringing over my roots. CHLOR, chlorite, hypobromite, phosphate. Oh, I went too far. pH. There we go. Phosphate, sulfite. Okay? So, you should have phosphate memorized or working on memorizing it. That's the ones that ask you to try to memorize. PO4 minus 3. Okay, so that's going to make H3PO4. Again, at any point where you're like, I didn't even know what to do, as soon as I've done enough that you can try the rest, pause it. Try to do as much as you can, and then continue watching. Pause it again as you need to. You need to try these on your own. Okay? Sulfite. Now, we're supposed to be learning sulfate, which is SO4 minus 2. So if that's sulfate, sulfite would have one less oxygen, SO3 minus 2. So this would be H2SO3. Okay? Chlorous acid. Chlorate is ClO3. ClO3 is chlorate. So chlorite would be ClO2. So this would be HClO2. Okay, and then hypobromous, bromate, that's a halogen as well, so it's going to be just like this. These are both 8s. So hypobromous would be BRO minus 1. So this would be HBRO. Okay? So you've got a few to practice. It's not a very big assignment. I know some of them this week have been a little bigger than others, but this one probably is the smallest, so it shouldn't take you long at all. Tomorrow I'm going to do you another quiz on naming. And then we do have our WebEx tomorrow at, I think y'all are at 12. No, you're at 11. This is if you're watching this on Thursday. On Friday we have WebEx at 11. And so we will talk through this. If you've got questions, you can email them to me ahead of time so that I can have my flip chart ready with stuff that you want me to talk about. And if it's just another topic that you want to be able to discuss with me, just shoot me an email and let me know you want me to put it in the WebEx flip chart, and I'll be glad to do that and talk through that stuff with y'all on Friday. Okay? Talk to you soon.